at the moment, but you get the picture. Now then we want you to think of, okay, what happens when you're done with it, and I want to add end of life. And when I add end of life, I have to select the material and say, okay, what's going to happen to this material? And it's dedicated again. And in this example, I'm going to select incineration. So I want this material to be incinerated, and I'm going to add it to the S-bomb. So now I have a material, and I shaped it, and it's getting landfilled. Now let's have a look at the results. When you go to results, the first thing you see is a scorecard. This is your main result. And in the scorecard, if you had uploaded a picture, you would have seen your picture here. And we call this the reference. So your first concept is your reference concept. You can change it around later. It has 36 millipoints of environmental impact. It's related to 1 hour of use, like you said. You see here the greatest impacts dedicated into materials, so the S-bomb input. The PET itself is most impactful. It gives you information about the impact category. In this example, it's a certification, and it gives you an idea of where that impact is starting. And it's in the manufacturing phase of your life cycle. Below you see a donut with the breakdown of all the different environmental impact categories that are included in your final score, the points. Now we can look at where these results came from. Here you see a total overview, and we see here that most of it was from the material, half of that from the injection molding, and the end of life added a little bit. And at the bottom of that column diagram, you see 3 things here now, but if your design is more complicated, your top 10 will be depicted here. And all these 10 could be starting points for you to start improve your performance. Now we also feature carbon footprint. If you click carbon footprint, a similar picture will show up. You can already see that the incineration at the end has a higher impact than the overall performance. And that can be realistic in your case. The carbon footprint doesn't necessarily align with your overall performance. We gave it as a separate indicator because everybody wants the carbon footprint and wants to know it right now. Okay. That's what I wanted to tell you about setting up a project and looking at results. Let's take you through a real example for a company of flooring material. So I pre-programmed a project here. It's a material exploration example looking into flooring materials. And one of the things that you see here is that if you look at carpet, carpet has basically 2 main components, which is the stuff you walk on, and then there's a backing. That's the material at the bottom. And we're looking here at the backing. The backing is usually made out of virgin material. And what we try to do here is say, okay, well, if we exchange some of that virgin material to recycled material, what happens? So what you see here is a comparison of a 2-layer 100% virgin backing material as compared to a 2-layer, but part of it secondary material and part of it virgin material. And you see here that there's a dramatic impact change in results. Now if we look at the overview of these concepts, and go back one screen, whoa, let's go back one screen, yeah, this one here. You see that we denounced one concept as a reference, and that's this product we're starting with. You've been working on different strategies with different amounts of secondary material. There's always one with a best score, but that doesn't necessarily have to be your final concept. For example, if the secondary material wasn't available for you. All right. Let's have a look at another project. Let's have a look at a project of a green phone. I'm sure you have been in the store and you said, okay, well, here's this Motorola or some other brand, and this is a green phone because the outer shell is recycled material, is a biopolymer even. So what we did is said, okay, let's have a look at a cell phone and see what's really important. And what you see here is an overview of the reference where we have 100% virgin polyethylene, which is a certain score, 1.2. And we looked at, okay, let's make it recycled, a different material, or recycled same material. And what you see here is that the result is an impact performance of about 50%. Now we can have a look at what that does, and basically what you're saying and looking at results and comparing the results is that by substituting polyethylene, which was the highest impact for the housing, because there was the material and it was just formed, and we changed it to a secondary material polyethylene. We changed it to that the injection molding became most impactful. So we did a improvement strategy on using low impact materials. Think about the eco-design strategies that we were looking at. Now, learning this, we said, oh, now we want to know, so now we know how we can improve the outer shell. Can we improve more? So we ran all kinds of scenarios and concepts where we said, okay, now let's have a look at the packaging. And here you see an example of the packaging itself. Now, we did some scenarios with packaging with secondary materials and virgin materials. The order of magnitude was still in the 1.1s, 1.5s, 1.6. So packaging and the cell phone itself, the shell, were in the same order of magnitude. Then we said, okay, well, let's have a look at the electronics inside here. So we ran a couple scenarios with the electronics. And looking at the electronics, we saw that the order of magnitude of environmental performance was 100-fold. We're going from 1.2, remember, to 120. So while we designed a greener cell phone by using secondary materials for the outer shell, if we can think of something for the electronics, then we'll probably have a better impact on sustainability performance than just looking at the outer shell. So whenever you see and hear somebody say, we have a green phone and it's about the shell, then you now know, you can ask, okay, but what about the electronics? We didn't stop there. The last scenario that we drafted was to have a look at the energy performance during use, because products get used, cell phones get used. And we see here that 2.1 times 10 to the third is in the thousands. So 10 times more important as the electronics is the energy use for just using the cell phone. And if you can implement a strategy comparing 0.1 watt powers to 0.35 watt power for the phone, you can make dramatic changes in impact. So use is even more important than the electronics. Now, if we look at a takeaway from this project, and you can frame it like this, and maybe you can relate to this. The user of this project was a sustainability manager for consumer electronics, and they wanted to develop credible solutions for the European market, where groups were interested in climate legislation and improving carbon footprint. The problem was that the most relevant improvements they wanted to learn about was climate change, and they started to evaluate green phones, and it was guided by their gut feeling. So they started to look into a bio-based plastic shell. Now, the result from using sustainable mindset is that using bio-based plastic shell is a pretty good idea if you only look at the shell. But what you just saw for an example is that the use-phase electricity and electronics created the greatest impact. So they learned that other things were more important. The significance is about a factor of 100, 1,000 if you look at climate change. Now, the decisions that they made is that they started a group called the Climate Leaders for Best Practice for component suppliers, and they rated them on toxicity compliance for components, energy efficiency operations, and their carbon footprint, because those were most impactful. Within all this discussion and all this guidance, if you then look at how long they needed to use sustainable mines for this project, it was rather quickly. The entire assessment, based on the scenarios that they drafted, of course, which took longer, but the assessment was less than 1 day. And if you look at the eco-design strategy in which lifecycle stages they were used, well, we looked at all of them and defined the bottom line. It's the electronics and the electricity consumption. And what they took away from that as key learning is that defining responsibility for a cell phone is defining it as a lifecycle concept and not just as a manufacturing step for what the company actually owns. Now, the last example that I want to give you is an example of a toaster project. Let's see if I can find it. Yes, it's here. It's the first project. We did a redesign project of a toaster, and if you look at the concepts, we did about 20 different concepts. But then again, there was a reference, the reference household toaster that was in function now. And we did some different redesigns using different strategies. The best score that we found was by producing a toaster using secondary steel. So I guess steel was an important component for this one, so material substitution. But the final concept we chose was a toaster that was designed for disassembly. So we could reuse components, so we could reuse all the materials at the end and give that a new life. Now if I look at the results view tab again, and the reason why I'm showing you this is to give you an idea of how you can use these results in your own software. For you look at the results, designed for disassembly. Again, you see the scorecard, and you see that there are differences in impact. You see that from the main list of impacts from steel, we switch it to copper. And by doing that, in the end, it doesn't mean we use more copper, we just reuse more steel. But in the end, the copper is most impactful. Now you see that in this overview. Now what you can do as a result, you can download the sustainable bill of materials. If you download it, a CSV file will open up, and you can export it to Excel or view it through Excel. And what you see here is a benchmarking project of the toaster. They're all different components in the toaster that you see the metal parts. There's wire, there's sheet, rolling, stainless steel, there's some low alloyed steel, there's some plastic components, there's some epoxy resins in there, there's packaging material in there. We modeled a certain power of use. At the end of the life cycle, a certain end-of-life strategy was programmed, and you see that there's some transportation involved. And all the numbers, all the breakdown of the environmental performance you can see to the right, which is broken down in all the impact categories and the total overview, including your carbon footprint. So you can use that information in your own presentations or in your own calculations. Now if we go back to results screen again, there's also a printable view. If you select printable view, a diagram pop-up will be calculated. And pop-up will start. And the pop-up will basically depict the scorecard that you have. And if you just copy-paste this, you can just include it in your PowerPoint presentation and say, okay, we've done a redesign. The most successful strategy that we chose and that you recommend, for example, to your management was applying design for disassembly and including a take-back program so that all those materials would be reused. And by doing so, you would have reduced the environmental impact by about 76%. So you can readily use the results. Now, one thing I didn't show you, and maybe we can go back to that, is the flooring project and the takeaway from that. We looked at different materials. It was a product strategy example. The user of this project was a strategic evaluation of direction for the company based on interest and questions from the market for a layer and furnishing. And the problem they solved is that they wanted to know, okay, how can we prioritize promising potential green product innovations that they know they work, and that they even set up a structure and infrastructure for it. They were at the design stage they looked at was direction. It was even before ideation, and it confirmed the direction that they had to go to. They had different scenarios. They made a decision to start a team to perform a feasibility study on the availability and technical performance of the secondary material that they wanted to be using, as from sustainable mines conclusions could be drawn, and have a look at the customer appreciation, whether this was a product that people wanted to buy or were willing to buy. At the time to use sustainable mines in that project was about half a day, and of course strategizing took a little longer. They used different strategies, and finally they said, okay, well, maybe a take-back system is good, and maybe we can look at delivering carpet as a service. Key learnings that they got from this is that recycled carpet showed the most direct environmental gain and the most easily implementable.